Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Good afternoon, everyone, and welcome. My name is Kim Ricketts, and I manage with Kirsten and Wiley the Microsoft Research Visiting Speaker Series. Today I'm happy to introduce to you Mark Buchanan. Actually, Mark, this is a visit back from Mark. He was here for discussing his last book. Today we are here to talk about a new way to understand why people do what they do. I've read the book, and I'm not quite certain which is more frightening, the idea that we are all individuals driven to act by a complicated set of individual traits and experience, therefore never understandable, or the idea that we move in groups in quite predictable ways, driven by an entirely external type of force. Clearly, if we study history and human behavior and find the patterns, if we can look at individuals as social atoms moving in predictable ways, we can understand and predict, which of course can impact everything from why we start wars to what the next fashion trend will be. It's a fascinating new social theory, kind of a mix of all sorts of the work that's going on now in various parts of the sciences, and Mark's here to discuss it with us today and answer our questions about it. Mark is a theoretical physicist, an editor at Complexus Journal, and the author of numerous articles and two earlier books, Ubiquity, Why Catastrophes Happen, and Nexus, Small Worlds and the Groundbreaking Theory of Networks. Before we begin Mark's talk, I want to ask everyone to turn off their cell phones so that the online audience won't be bothered by the static. And please join me in welcoming Mark Buchanan to Microsoft Research.
Thank you very much, Kim. It's a pleasure to be here and to be invited to say something about this new book. I hope I can do some form of justice to what's in the book. One thing you learn when you write books is that they make you look far more intelligent than you really are, because over the span of a year you get to weed out all the stupid things you wrote down at the beginning and replace them with the one or two good thoughts you have every week. And in the end, you've kind of, by an evolutionary process, produced something that doesn't look nearly as stupid as you really are. So before I actually get into what the book is about, I'm going to actually put my introduction into the book kind of in the middle of the talk. So I'm going to first start by talking just about some ideas from physics for the first 10 to 15 minutes. And then once I've done that, to establish a kind of way of thinking and some concepts, then I'm going to come back and give the introduction to the talk in the middle, and then move on toward the end of the talk from there. So let me just start off by talking a little bit about some simple experiments, or one simple experiment in physics and the surprising outcome. So suppose we take some tiny beads, ball bearings or glass beads, what have you, put them in the bottom of a container, so it makes a thin layer on the bottom, and then we begin to shake it up and down. We can adjust the frequency and we can adjust the amplitude, how far we're shaking it. Turn it up. What do we expect to happen? Well, at some point, obviously, when the acceleration gets large enough, the grains are going to start bouncing off the floor, and you're going to get some kind of gaseous material there. But at least my intuition wouldn't tell me that anything really interesting is ever going to happen in such an experiment. This experiment was actually done, and there's work continuing in this kind of stuff. Harry Swinney, who's a physicist at the University of Texas. So the left side of the screen shows the apparatus. So there's a camera above the chamber. He actually evacuated the container, so there's some tiny ball bearings in the container in vacuum. And then on the right it shows how he took an image of it. So he shone light in from an oblique angle. And the idea is if you found any interesting patterns that emerged, the light would bounce off the upper regions and wouldn't ever make it into the kind of divots down at the valleys. And so what you'd see is the upper regions from above, and you wouldn't see the valleys. So they started the experiment and changed the frequency and amplitude, and the following picture shows the kind of thing they found. Starting at the upper right, so up here, this is the condition at fairly low frequency and low amplitude. What you find is nothing very interesting. You just have a homogeneous layer of the ball bearings, no interesting patterns. But at some point you pass a threshold and there's the uniformity of the featurelessness breaks apart, it becomes unstable, and what you get is these kind of patterns that emerge. And sometimes you get, depending on the frequency as you increase, you get square kind of patterns. Sometimes you get hexagons that form honeycomb patterns. sometimes you get the dish will have one pattern in one region with a boundary bleeding into another kind of pattern in another region. And this can all be explained in physics terms fairly simply in terms of, it involves some mathematics, but what you find is these sinusoidal patterns at a certain frequency become unstable. So a little bit of that pattern knocks the grains around in such a way that a moment later you have more of that pattern. And it feeds on itself until some other process comes into play and stabilizes it at a certain level. So this is kind of self-organization of patterns that apparently more or less come out of nowhere. And the important thing to, I think, conceptually is that there's no way looking at a single ball bearing you'd ever predict that this kind of thing would emerge from this really simple experiment. The patterns have something to do with a global organization at a higher level. Looking at single ball bearings tells you very little about them. Just one other pattern that they found in these kinds of experiments, these are called Oscillons. And they're actually very localized, kind of pulse-like patterns. This seems to show that there's a kind of an array of them. That's not necessary. You can set up 1 or 2 or 3 of these. And they're actually like little particles. So 2 of them will kind of repel one another and move around. They'll go into orbits, move around. There's actually 2 kinds of particles because this is oscillating. A half cycle later, that pulse is actually a divot. And if you take 2 of them that are out of cycle, so one's a divot and one's a pulse, they'll attract one another like particle and antiparticle, and they can annihilate. So it's a fascinating kind of world of organized physics that occurs at this higher level above the level of the single beads. And again, you wouldn't expect this just by looking at the single beads. It has to do with the organization at this higher level. One final example from geophysics of this kind of spontaneous patterns. This is a picture of a tundra in Spitsbergen, which is an island in Norway, in the Arctic. And I think many people, if you saw these perfect or near perfect circular rings of stones, you might think that some local tribe had kind of went out there and swept them up into this ordered pattern for some purpose. In fact, that's not the case. This was explained only a couple of years ago now, but this is also the product of an instability that emerges out of the tundra. So if you went out there with a broom and swept this all into a fairly ordered regime, this would come back again. And the process is fairly simple. It involves freezing and thawing. So that wherever you have a bit more soil, the soil can collect a bit more water. Places that have lots of stones can have less water. When the tundra freezes, you get differential expansion because the thing with more water expands at a greater degree than the place with more rocks. So this tends to force rocks together, this differential expansion, and there's repeated cycles of freezing and thawing. As this happens, another factor comes into play, which is that as piles get bigger, rocks start to tumble down in the other direction. So this lens tends to create these kind of tubes of rocks, ridges, and under some conditions they can turn around and connect back to themselves and create these rings. In other cases, you'll find hillsides that are covered with these kind of ring-like patterns, forming snake-like picture. The interesting thing again is no study of the individual rocks or the soil would tell you that this is going to come out of the wash. This was explained by some geophysicists at University of California a couple of years ago, and they've done it with simulations, and it all works out quite well. Finally, let me just talk about physics proper, or the physics of at the molecular scale, physics of solids and liquids. Again, the same kind of principle holds true, that organization is often more important than the constituent pieces. So, water is water. It can be solid or liquid. Same molecules are involved. There's 12 different phases of solid ice, all with slightly different physical properties. Same molecules. It's all organization that really matters. There are at least two phases of liquid water that are also different in their physical properties. And the difference comes down only to the way that the water molecules are flowing about one another and the correlations between their positions. The other example, of course, is carbon atoms. The same carbon atoms make up both shiny, super hard diamond or make up soft gray graphite. So the point is that at all these levels, whether it's geophysics or billiard ball bearings in a dish or down at the molecular level, organization is fundamentally important, and it's more organization that counts rather than the particular kinds of atoms or molecules involved. So with that little burst of physics in there, what I want to really ask is what about people? This way of thinking is important in physics and in physical sciences in general. We understand that we need to know about these collective patterns in order to understand systems, that knowing the parts isn't enough. What about social sciences? Are there examples of similar kinds of collective order in social systems? What do we know about them? Can we understand them? There are, of course, a number of examples of this. This is something from just a few years ago. This is the London Millennium Bridge. It's the longest pedestrian bridge that's built over the Thames in several hundred years. And it was opened one day in June of the year 2000. And then it was shut down in the afternoon because it was swaying back and forth side to side by about 8 to 10 centimeters. And so they shut it down. Engineers went to work trying to figure out what was happening. Now, it hadn't started swaying until about 200 people got onto the bridge. And the explanation that has eventually been proposed and seems to be the correct one is that it had to do with a subtle interaction between the way the people were walking and the way the bridge could sway. Now, I understand that the military has some kind of particular order that they give troops when they're marching across a bridge to fall out of step so that they aren't in synchrony and they're not pounding the bridge with hundreds of steps at the same moment. So they fall out of synchrony. People walking on the bridge would have naturally been unsynchronized to begin with. But the theory is that with about 200 people, just the statistical fluctuation would have given enough push left or right, enough of an alignment just by statistics, that the bridge would have swayed just slightly. That swaying would have caused people to start to synchronize their steps with the swaying because it's easier to walk. That makes the people become more synchronized with each other, which makes the impetus they give to the bridge even larger. And the other thing is, the impetus they're giving in the way they're walking is actually making the bridge sway more. So you get this feedback in the way that the people push the bridge moves, it affects the people, they synchronize, they push the bridge more. And when it got to about 10 centimeters, that's when they shut down the bridge. Since then, they've put some big stabilizers on the bridge, and it can function again. So that's an interesting thing of where you have this kind of self-organized social pattern, even though it's just walking, and in this case mediated by the bridge. Now there's a small tradition in social science of understanding this kind of spontaneous order, and it actually goes back to the 70s. Let me just talk about this for a couple minutes. So racial segregation is a long-standing problem, in particular in the U.S. So this is a picture of, or a map of, I forget what area, I think it's South Carolina, or maybe it's in Virginia, I don't know. In any event, what it shows is that the yellow regions are places when it's almost homogeneous white population. The dark brown regions are places where the population of blacks is very high, so they're kind of located in homogeneous enclaves. Now, the real puzzle about racial segregation is that the level of segregation hasn't changed much in the past 50 years, but people's attitudes towards segregation have changed a lot. So in the 40s, it was socially acceptable and quite popular for people to think that the races ought to be segregated, that was the best way for society to be run. By the 70s, and even more so today, that's not the socially acceptable and common way of thinking. We think that racial integration is a better approach, yet still the segregation persists. Now, a proposal for why this might happen was made in the early 70s by Thomas Schelling, who's an economist at Harvard back then. He recently won the Nobel Prize, but not for this work, for different work. And his idea was that there may be kind of hidden forces, almost innocuous forces that might make the races kind of separate into enclaves that have nothing to do really with kind of racialist attitudes. So he explored this in the following way. He said, suppose we start out with a perfectly well-integrated community. So I'll talk about blues and greens here. So I just sprinkle them onto the landscape at random. And suppose that no one's racist, everyone's perfectly willing to live in an integrated mixed community, but we'll make one small assumption about human nature, that people don't like to be part of an extreme minority. So someone who's in an extreme minority of, say, less than 20%, looks around themselves and finds less than 20% of a similar color, is uncomfortable, and they'll decide to move to another random location in the region. What is this going to lead to in the long run? Now, what Schelling actually explored this with, this is before computers were widespread, so he explored it with a grid of paper and some coins, and he used to sit with his son over the dinner table and play this in the evenings. And of course, nowadays we can do simulations. So this is one I found. Lots of these are available on the web. So this is a grid work where the colors in this case are yellow and blue people, and the black is open places where people could go and live. You might think of the black as houses where people could go live. So we start with a fully random distribution. We just sprinkle the people on there in a well-integrated community. And then now we play the game where we pick out a person at random, look in their vicinity. If they're not in an extreme minority, we leave them there. If they are in an extreme minority, we send them to another random location, a black square, somewhere in the thing. And what you find is that fairly quickly you'll get a kind of segregation. And it's not too hard to understand why. I won't go into the details, but we could talk about that later if you want. In any event, over a short period of time, this kind of simple and innocuous behavioral preference actually leads to the production of fairly homogeneous enclaves and kind of separates the races more or less like oil and water. So the interesting point from Schelling wanted to point out with this example, this doesn't prove that racism is not important. That's not the logical conclusion. It just shows that if you see racial segregation, you cannot conclude that it must be racism and racial attitudes that are causing it. There may be some other process, kind of mechanical process, that could be contributing. So what it proves, I think, is that the link between individual attitudes and collective outcomes is not at all straightforward. There's this puzzle in going from the microscopic to the macroscopic that is not at all easy to do, and that mechanical forces kind of operating outside of our awareness can in principle be very important and even affect things as important as racial segregation. So the question, this is going to end my preliminary intro, and then I'll do the intro to the talk. So the question is this kind of just the tip of the iceberg? Is spontaneous order more pervasive than this in the social world? Does it affect things like crime and education? Does it influence what we think and what our values are? Does it really get inside of our heads and kind of are there mechanical processes that push us this way and that we're not really thinking about as we go about our lives, thinking we're independent, free-willed people making up our own minds? Well, obviously the answer is yes. There's all kinds of things like fashion, waves of hysteria, market crashes and bubbles with economic consequences. There's social norms that most of us don't feel comfortable violating. All these things do affect our values, our thoughts, and so there are obviously collective forces, and a lot of social psychology and sociology has gone into studying these kinds of things. But it turns out that learning how to do the science of this kind of spontaneous order in anything like the same kind of way it's done in the physical sciences has not been obvious at all, at least historically. And so that ends the preliminary introduction. So now the introduction is, why have I written this book? And the reason I've written the book is that I think social science is really changing very, very rapidly now for several reasons. One is lots of experiment in experimental economics and in psychology and in neuroscience that is giving us a better picture of how people really behave. And the second thing is that there's a lot of work done with simulations and our ability to probe the link between the microscopic properties of people and the kinds of things that you're going to find at the macroscopic level. That link just defeats the human mind in terms of conceptual complexity, but we now have some ability to probe these things. So let me go through my kind of introduction in a little more detail. If economics, social sciences have been kind of invaded and threatened and almost taken over by economics. I wouldn't have known this because I'm a physicist by training, but when you start reading in the field, you find out that the economic way of thinking in terms of rational, greedy behavior, cost-benefit analyses, has kind of tried to invade all of the social sciences and tried to explain lots of phenomena that you wouldn't think have anything to do with economics in terms of that economic reasoning. So in these the typical models, people are, of course, rational and selfish. I think somehow this has its roots in our desire to see ourselves as being fully kind of distinct and separate from the animal kingdom. There's this line in the biological world. There's us, and then there's the rest of the world that's all instinct. We're different. We've got reason. We're conceptually driven and in control of our lives in a different way. This idea has been applied to crime, to explain crime, why people have children, why people are depressed. The big guy is Gary Becker, who won the Nobel Prize in 1992. So depression is looked at as a way of renegotiating a social contract between two people. So if I get depressed, you've got to make some changes in the way you're treating me. Why people have children, in his Nobel Prize lecture, Gary Becker explains that a large part of why people have children, it's not really biology that's driving that. It's actually an investment in your long-term financial future, because your children are going to look after you, at least to some extent, in your old age. And finally, applied to crime, Becker says that people commit crimes because they do a careful cost-benefit analysis, that in their present situation, they reason out that committing a crime, even with the risk of punishment, is actually the sensible thing to do, and that's why they commit crimes. The reason he tells a story about why he came to this view, and he was late for he was supposed to be on a PhD examining committee, and he was late, and he had to park in an illegal spot. So what he did was he thought about it, and he quickly sat down with a piece of paper and did some calculations, worked out the costs and benefits, the likelihood he would be caught, what the fine would be, how much time he'd save, and he came to the conclusion that he should, in fact, just park there. And lo and behold, he didn't get a ticket. So this started him on a long course that won him the Nobel Prize, and actually went on to infect lots of thinking in social science. Of course, economics is a highly mathematical, sophisticated mathematical subject, all based on this assumption that people are thoroughgoing kind of rational machines with near infinite capabilities. Why has economics been infected with that particular way of thinking, and why has it become so dominant? If you read many of the great economists of the present day, somewhere along the line they all say this is ridiculous. We shouldn't have to think about this, be stuck on this assumption. I hope we can get beyond this. But then they go back and in all their models they assume it nonetheless. One very interesting idea put forth by Robert Axelrod, who's a political scientist, is that the reason this rationality assumption comes into all these models is that it makes the messiness of human behavior, our differences, the fact that we make mistakes, the fact that we've got psychological biases, it wipes all that off the screen and reduces human behavior down to one simple thing. We're rational and we're greedy. It makes problems in understanding human behavior problems in mathematics. So it makes everything perfectly definite so that you can build theories on the basis just of logical deduction. You don't need to worry so much about experiment and empirical reality. But everything is now changing, and it has been for the last 15 to 20 years. I think it's really picking up momentum now. All the best graduate students are going into things like behavioral economics and experimental economics, where they're actually looking at how real people behave, how real people think, how they make decisions. And the view of perfect human rationality has been thoroughly debunked. I just thought I'd go through one tiny little example just because it's kind of fun. A bat and ball together cost $1.10. The bat costs $1 more than the ball. How much is the ball? Now this is a high school level problem, even lower than that. But there's a good chance that most people in the audience will at least feel a desire to give the wrong answer. Since you're all scientifically trained, you're probably cautious enough not to give the wrong answer before you check it. But of course, the easy answer is 10 cents because it just sticks out at you and it's about the right order of magnitude. The right answer is 5 cents. It's a little bit more difficult to get to that answer. And there's an experiment that was done with university students at Princeton and Michigan several years ago, given 15 minutes to think about it, and 50% of them still gave the wrong answer. Now there's a psychologist, Daniel Kahneman, who has this view of the human mind as kind of two minds. One is the instinctual mind. That's the part that wants to make you say 10 cents. And then there is the reasoning mind that is, the instinctual mind's quick and effortless. The reasoning mind is difficult and laborious. And those students just couldn't bring that censoring mind into effect. At least 50% of them couldn't. So kind of the view, just to do it very quickly, the view that's emerging from all this kind of work is that we're less rational and calculating than we tend to think. We're more intuitive and biological. We act on rules of thumb. We're especially skilled at adaptive thinking and reaction and tuning our behavior, learning. in short and kind of very loosely speaking, we're kind of akin to social atoms who follow relatively simple rules. So that's where I make this kind of loose analogy to the idea of atoms. The atoms in the physical world go together in patterns to create order in the physical world. We're the social atoms that go together in various ways to create order in the social world. Tremendous differences, of course, because we can learn and simple atoms in the physical world don't. That's as far as the analogy goes, but it's just a nice way to think. Okay, so my claim in the book, and what the book is basically doing is going through lots of arguments to support this, is that the social sciences are being transformed not only by all this work at the level of psychology and individual human behavior that tells us that people are in many ways simpler than we thought, but also that what you find in the social world, the kind of organized collective patterns that arise, often have less to do with the individual complexity of the human being than they do with the combinatorial complexity that leads to organized patterns at the higher level, just like we saw in the physical world of the stone rings or the weird Oscillons in the vibrating dish of ball bearings. I just thought of one other experiment I might tell you about. This is a really weird one. This is a guy from Amsterdam. He's a psychologist. He had students. This is kind of a Blink example, but it wasn't mentioned in the book Blink. He had students come to a lab. He split them into two groups. Some of them talked for a while with an actor who played a professor. So he was apparently very intelligent and learned and knowledgeable. Then they had another group talk to a guy who's another actor portraying a soccer hooligan. So he had earrings and was very, apparently abusive in his language and crude. After this, they gave them just a general knowledge test. And the people who had been with the professor scored significantly higher than the people who had been with the soccer hooligan. So that's really scary if it can actually get into your mind and make you answer questions either right or wrong, flip you one way or the other. Now, whether that can be replicated or not, I don't know. And I think there's some controversy over that. But in any event, let me just continue now. Having done my introduction, I'm going to move on to a few examples, and then I'll be getting toward the end. So a few examples of what I want to talk about is kind of ways that mechanical kind of behavior seems to influence us and lead to important social outcomes. This is a picture from a study called Divided They Blog, which is done by Lotta Adamek at Hewlett-Packard and Natalie Glantz at some other private company. This is taken from data just around the 2004 election between John Kerry and George Bush. So the blue dots represent liberal bloggers on the web. The red dots are conservative blogs. And what it shows is the links that go from any one of these blogs to any other. And what you find is that these two sets of bloggers form kind of fairly distinct communities where there's lots of red guys linking to other red guys, lots of blues linking to blues, but there are a dearth of interconnections between the two communities. So this is kind of standard definition of a community, something that has many more links within it than it does to links elsewhere. Question is, why is there such polarization? One idea might be that maybe bloggers by nature are just extremists. The people who blog are those who are extreme people. That's a possibility. I'm not going to explore that idea. I'm going to explore a slightly different explanation, which is that maybe this kind of polarization actually emerges and grows and feeds on itself and could emerge even if bloggers weren't so extreme to begin with. So the idea is maybe there's a kind of ideological amplification. First of all, let me talk about some other experiments that were done just recently. I haven't been published yet. Among legal people, there's apparently become popular this idea of deliberation day. Maybe we should have deliberation days in the U.S. where people can get together and talk about their political views about all the different issues. Maybe that will help our democracy to function better because people share views, learn what other people are thinking and why, so on and so forth. Well, they did some experiments to see what would happen in this kind of thing. So they got some people from Boulder, Colorado, who were fairly liberal in their views, and they got people from somewhere else in Colorado. I think a place, I can't remember which town it is, but there's a big Air Force base, perhaps. Anyways, they're conservatives in this town. So they had these two groups come, and they had them. First of all, they took a survey to find out what their views were at the beginning on the various issues. They then let them chat with each other for 5 hours and talk about everything. And what they found at the end was that both groups had become much more extreme in their views. So the liberals talking to the liberals just confirmed their own beliefs, became actually more extreme, and at the end of the day in the survey showed that extremism had actually grown. The same thing with the conservatives. They became more conservative. The division between the two groups increased, while within the groups the consensus became more definite. So people just talking amongst themselves can make themselves more extreme and also lead to a consensus among them. What are the mechanisms for this? One is just conformity. People will defer to the opinions of others. They'll absorb the opinions of others. They may encounter ideas they hadn't heard of before and be convinced by those ideas. There's the notion of people like to have a shared identity and feeling part of the group. You can feel more part of the group if you kind of absorb and take on the views in that group. Those would apply to this deliberation day experiment. I think there's something else at work in the web is where you choose the sites you want to link to. In these experiments, people were just put in a group, they talked, and their views changed. In the context of the web, you're not just put in a group, you choose the group. And the well-known phenomenon of cognitive dissonance is that people feel a real psychological discomfort in confronting and dealing with and thinking about views that they really disagree with. So there's going to be a kind of selective biasing of the choice of websites you visit just by the fact that they tend to say more of the things that you tend to agree with than do others. So this is not really an explanation, but it's a sketched possibility for an explanation of how the kind of psychomechanical kind of process can lead to an increasing amplification of ideology within something like the web. Yeah.
So the two groups, were they separated and talking among themselves, or were they interacting?
Yeah. No, they were talking amongst themselves.
So there was no interaction at all?
No.
Because just my experience have come across that, so if I'm talking to someone who's opposed to my view, I become more and more, I try to, I feel under attack and try to move closer to my view. Like the conservatives become more conservative and the liberals become more liberal. But the opposite effect is also seen, right? Because if you talk to somebody, a conservative talking to someone he believes is more conservative than him or her, you tend to move away from that position too.
Right.
I'm not sure how these two reconcile, so.
Yeah, I agree. It's not at all clear. This isn't a finished subject at all. But apparently some legal theorists started proposing an idea of like foreign exchange between liberal and conservative communities. So I just want to finish with two examples. Okay, this is kind of empirical, experimental. We can look and see what people do. This is really just social psychology of the way it's been done for a long time. I think what's really new about social science now is one, all the experiments that are giving us a better idea of how people behave. The second thing is what we can do about this in terms of trying to understand patterns that emerge. As I've talked about already, the biggest problem in the social sciences is this understanding the macro or the micro to the macro divide. How simple rules, when many people get together, lead to patterns that they're by no means obvious. And I think it's increasingly clear that there's lots of work going on in computational economics, computational sociology, that people are starting to realize that the only means nowadays available for exploring this kind of computational or the kind of order that emerges in these collective systems is through computation. Maybe there will be other ways in the future, but there's nothing available now, and that this is immeasurably more powerful than anything that's ever been used in the social sciences before. So let me talk about two examples of where this is being used, at least to formulate hypotheses and show some interesting effects. The first thing, sorry, I'm cutting off a few words there, but I think I can get past it anyways. First thing is in modeling markets and so-called strong fluctuations. So one thing about financial markets that economists have never been able to explain is that they're subject to large fluctuations much more frequently than they would be if they followed ordinary bell curve kind of Gaussian statistics. So how long you have to wait before you see a single day drop of 5%. If you predict what that is by Gaussian statistics, you'll find it's like 500 years. If you look empirically, it's about 10 to 15 years or 20 years. Right? So markets tend to be subject to these large fluctuations more frequently than you'd expect. One way, so how do you explain this? Well, the best models nowadays for markets are models that do not assume perfectly rational investors the way economic theory has in the past, the so-called efficient market hypothesis. What it's based on instead is a computational model where you use in adaptive agents. You build up a market in the computer. So each of your agents, say you put 1,000 agents in the model, each one is going to look to the past record of prices, the ups and downs, and is going to keep in their head a number of theories about how past prices might predict future prices. So one theory might be, if it's gone up 3 days in a row, it's going to go up again. Another theory might be, if it's gone up 3 days in a row, it's going to go down this time. Another theory, if it's gone up and down, then it's going to go up. Now you can imagine a whole spectrum of possible theories. Well, the idea is that how do we behave in practice? We don't always just make up try to calculate things from first principles. We have ideas. We act on them. The ideas that tend to work, we tend to believe more. The ideas that don't work, we throw those away. We try new ideas. So the idea of these models is to create these artificially intelligent agents. Each one keeps a handful of strategies in their head. They keep comparing those strategies to how the real world is working. And at each moment, they use the one that seems to be working best in the recent past to make their choice about what to do on the next day, say to buy a stock or to sell a stock or just not to take part in the market that day. So what you do is you set up the market, you put in all these agents, you give them strategies, you start trading, and the price in the market actually responds to what the people do. So if there's more people buying today than selling, that's going to tend to push the price up. If there's more people selling than buying, vice versa, the price goes down. The people follow these price trends, make up their theories, trade on the basis of those theories. Their behavior leads to changes in the prices, which feed back into the behavior. So it's a self-sustaining kind of market model. You can also put in information flows from the outside if you like. What's interesting is that what you end up with is kind of market as an ecology of interacting beliefs and expectations, which has natural fluctuations. It never settles down. The price continues to fluctuate. And it exhibits natural, strong fluctuations. So you find the mathematical behavior of the market is much closer to real markets than any kind of traditional economic model. In particular, it gives you these large fluctuations that occur more frequently than you expect, even in the absence of an external shock. Now, there are many studies in economics that have shown that over the past 50 years, you can explain, of the largest 100 events, you can maybe explain 50 of them in terms of some obvious external shock, some kind of political crisis. But the other 50, there's just no apparent event whatsoever that could have caused a large 3%, 5%, 10% change in one day. So this kind of model leads to this behavior quite naturally and as a matter of course. What's even more interesting is that these models are now quite capable of predicting market movements. This is the work of Neil Johnson at the University of Oxford, and it's fascinating how he does this. It starts with the idea that this model, right, how do you predict a market? One is you might write down some equations, try to fit them to a past sequence of prices, and use that to predict the future. His idea is that this model, because it actually reproduces realistic market behavior, it might be the most sophisticated mathematical object we have for trying to predict a market as well. So what he does is he takes it and first of all he trains it up on a couple months worth of data. And so basically the things that are parameters inside the model are the strategies that the people are using. So what you can do is you can take the model, you try to make it reproduce 2 months worth of data. If it doesn't quite fit, you fiddle with the strategies that the people are using, the distribution of strategies. See if it gets closer. Do a kind of evolutionary search as you change these strategies until you get the model to reproduce that 2 months worth of data. Then you have the suspicion, or hope at least, that somehow what's happening in the computer, all those thousands of people who, with all their different strategies, you're capturing something about the collective structure of this ecology of underlying beliefs that drives the market. Then you run it one more day forward, and whatever happens, you make a prediction. And what they found is that they can I can't remember the exact details, but it was like in 400 days of foreign exchange data, they were able, first of all, to identify 90 days when they thought they'd have very strong accuracy, so windows of predictability. And what those were conditioned on was days when the ecology of strategies showed that many, many people were holding the same kind of strategic behavior, so likely to do the same thing on the next day, which would move the market in a significant way. Then looking at those 90 days and making predictions, they got the right direction of the prediction wrong only once. So that's pretty good.
Everybody would use the same tools and what happens?
Absolutely. There's no way around that. I think, this starts to work, banks will start using it, and things will change. And that's you're always going to be stuck with that in social science. People learn theories, and that's going to feed back into their behavior, and in a situation like this, that's going to change how the market works. So finally, let me just finish one other example in a totally different area. So this is more kind of fundamental social science. You can think of the market bit as kind of applied. So fundamental social science. Ethnocentrism is a widespread and kind of, we think, unfortunate pattern of behavior. People who are kind of bigoted, they see their own group as best, other groups as inferior. My values are obviously superior to yours. You see this played out all over the world and throughout history. Why is this such a prevalent behavioral trait? Why does it persist against apparently all attempts to get rid of it? One hypothesis that was suggested a couple years ago is that this kind of behavior, this kind of attitude, even though it's quite ugly and we'd rather not have it, at another level it's actually quite important for supporting cooperation within groups, at least under very primitive conditions. Now let me just go through how the logic can lead you to this kind of conclusion. So first of all, let's just imagine a world that is totally unlike our world. So how do we learn to cooperate with each other? First of all, it's because we've had some prior experience with each other. I know that the person I've interacted with has been trustworthy in the past. I've interacted with them 10 times. They've cooperated every time. They haven't tried to cheat me. I believe that they're a good person. I looked at their character and personality. Or I know that I've talked to Kim and she says that you're a good guy, and so you have a reputation and I can trust that. So these are higher mechanisms that we use all the time in our lives to manage to cooperate. Suppose there's a world where all that's wiped away. So people, you just have no memory, for example. So each person you meet, you don't remember what they're like. You've never interacted with them before. You can't remember it. There's no reputation. So each meeting you have with the person is just like the first time you've ever met them. So if you imagine this world, you can think of it as a bunch of people interacting, and to make the world very simple, we can just make their interactions just a kind of prisoner's dilemma kind of game. So they stand to benefit from cooperation if they can manage it, but it's a bit risky because each one has the incentive to cheat, and if they cheat, they'll get more at the other one's expense. So it's a difficult kind of thing to manage. And in the absence of any of these higher mechanisms for achieving cooperation, there's really nothing you can do. You can just take a guess. You can cooperate, you can defect, you can do what you want, but there's no good way to manage cooperation because there's no way you can learn about what the other person is likely to do. So then add to this world just one thing, some colors. So now let's let people come in 4 different colors that are totally meaningless, right? A green person is no more likely to cooperate than a red person or a purple person, right? So the colors are totally meaningless. They're just superficial traits. But it's under some circumstances, this is work of Robert Axelrod and Ross Hammond, Axelrod at the University of Michigan. Under some circumstances, it turns out that this kind of, just having these colors available that lets you differentiate people can act as a kind of scaffolding that lets a population kind of grow more cooperation than it would otherwise. Now here's how it works. So what they've done in this kind of agent-based model is the following. So they have this population, 4 different colors of people, and they just give the people random strategies, assign strategies at random to these people. So in this simple model, there's 4 different strategies. You can always cooperate with everyone you see, regardless of their color. You can never cooperate with people, regardless of their color. The third is you can cooperate with people who have the same color as you and not with anybody else. And the fourth is the opposite of that. You can cooperate with people of the other colors, but never with the same color. So you assign these strategies. You assign colors to people at random, totally meaningless. You assign strategies. You let people start interacting in pairs at random. And the people who are more effective in managing to cooperate, you assume they get some kind of payback from it, more food, more money, whatever. They have more offspring, or you can do it a different way. You can just say that other people will see that they're being effective and can copy that behavior, that strategy. And you allow for some moving around. People can move around a bit in the population. And what you find in these simulations is that very quickly you get about 75% of the people start using the ethnocentric strategy. So this emerges naturally and repeatedly. And the people segregate into kind of enclaves of racial or color homogeneity. So what happens is that the meaningless traits, the colors, actually come to mean something. Because once you get inside an enclave, you're surrounded by people who are the same color as you, and they're all using the ethnocentric trait. So in fact, they will cooperate with you, but the people from the other colors won't cooperate with you. So the colors take on a meaning, even though they're totally meaningless at the outset. They're information handholds that let the community organize itself in a way. And what's interesting is you get a higher level of cooperation in the overall community than you did in the first case, where you had no information whatsoever to go on. So this is very tentative work. Does this apply to the real world? Is this why you get more ethnocentric behavior in places where there's social breakdown, economic breakdown, where the ordinary means of cooperation have maybe been disrupted? That's a big question for the future. But the interesting idea is that possibly this kind of ugly trait that we all think we'd like to get rid of may serve some function, or served some function in primitive societies, and that's why it kind of hangs around today and is very difficult to get rid of. And presumably it may have been, over a long period of time, kind of biologically hardwired as well. Okay, so finally I'll just end with the conclusions. The idea is that social science isn't just about understanding people and what their preferences are and what they'd like to do. It's about the patterns that emerge, even though lots of people didn't even want them to emerge. Computation is currently the best tool we have for kind of probing this kind of spontaneous social organization. And social science, in a way, is a little bit like physics. I mean, the way I think about it is, condensed matter physics of liquids, solids, superfluids, superconductors, all that kind of stuff. That's what 75% of physicists work on. And it's a huge open-ended challenge, because you can put atoms together in so many different ways. 20 years ago, we discovered that if you took 4 different kinds of atoms and stuck them together in a particular way with some copper and oxide in a sheet, you get high temperature superconductors, and we still don't understand where that kind of spontaneous order comes from, how it emerges. It's a huge project to understand even these simple parts with just hardly any degrees of freedom. When you put them together, the kinds of things that emerge. Social science is putting together objects that have many more degrees of freedom. And presumably it's going to be a much richer and more open-ended project than physics. But in this sense, it is the same kind of project of exploring how order and organization emerges from the interactions of relatively simpler objects. And finally, I like the speculation. What would the great social philosophers like Hobbes and Smith and Weber, what would they be doing today if they had access to computers where they could explore and push the powers of their minds further to follow chains of cause and effect, where the web of interactions quickly overwhelms our mind, our capacity for imagination? And I think they'd be doing computation rather than writing long essays.
We're all computer people here. I'm sure most of us did our own experiments with the iterative genetic prisoner's dilemma when we were at school or college. I did it with my friends. We all got very, very different conclusions. Some of us had chaos all of the time. Others had generations of peace followed by generations of war. It feels like this is the same sort of thing. One of us could have written a paper saying 75% will be like this, and someone else could have written a completely different paper. And so we wouldn't have actually got any real answers. It feels like there has to be something that lifts this up from just knocking people doing self-justifying experiments into turning it into a real
somehow you need a research program where, and unfortunately, agent-based modeling is so easy to do that lots of studies get published and no one ever bothers to try to replicate the study. And that's it. There it goes. They just go on and do, someone else does their own study on some slightly different conditions. What you need, I think, is something quite similar to what's happened with climate modeling. Over the past 20 years ago, climate models were in a fairly sorry state, and there were many different models, and the models that were being used weren't often replicated by other groups. But something that I think maybe the National Science Foundation in the States did was set up a program where everyone had to share data and try to replicate the results achieved by other models, and to try to bring everyone together so that you can do real science in a productive, repetitive way. And I think that's the same kind of thing that has to happen in this field, because you're right, you can put the same simulation on two different computers and sometimes get the different result.
I was just going to ask, it seems like a lot of them are very sensitive to initial conditions, and are they sort of starting with enough different initial conditions or enough small variations in whatever rules that you're using?
Yeah.
And then making sure that the results don't diverge.
Yeah, you have to explore all those things. For example, in the Schelling model that I showed, that starts from a random, I just sprinkle people on there randomly. If I set them up in a grid work with a green person surrounded by some yellows and some greens, kind of in a grid work, you can arrange it so that no one is actually in a strong minority. And that would be a stable state that would stay there forever. So that's a fairly rare and unlikely initial condition. But of course, you need to explore the distribution of initial conditions, how, what's the basin of attraction for the kind of model.
I guess you're arguing that social science would become more like statistical mechanics, but I'm wondering, in what ways do you think social science is going to be different to statistical mechanics? In other words, is it all going to turn out to be ensembles?
No, I don't think so. I think social science is going to turn out to be much richer than statistical mechanics, because the elementary parts are quite sophisticated things, and so I don't think we're going to come to a situation where ensemble kind of equilibrium picture is going to explain much of anything. It's most of these models are about out of equilibrium dynamics and systems that continually churn over. These market models, they don't settle down. It's just a perpetual evolution. But in physics as well, we don't understand a whole lot about non-equilibrium physics. So I think where that's going to go in the future, I don't know either. There's a lot of things you can't do in physics other than just with simulations at the moment. Yeah.
So early on in the talk you said that the new view shows that in fact the simple rules that individual people follow are actually fairly even simpler than was thought earlier on. But I didn't see you mention some of these rules, or perhaps these haven't been all discovered yet.
I talked about them some in the book. Simpler in the sense that often our behavior is fairly mechanical. Not simple in the sense that you can write down 3 rules and that's what we do. Maybe there's 250 rules, I don't know. But our behavior is often more mechanical. Some of the things I'm talking about is, there are these famous experiments by Solomon Asch 50 years ago. Do you know about? So he had volunteers come to the lab, and so you're going to take part in an experiment on perception, and I'll show you a piece of paper with 3 lines on it of different lengths, and you're supposed to tell me which one's the longest, right? And they're different enough so that it's not hard to do. So if you just came in on your own, you'd get it right every time. But the way they set it up is you come in as part of a group, and actually everyone else isn't really a volunteer. They're all they're working for the experimenter. And what they do, they arrange it so that the other people give their answers first before you are chosen to answer. And they find that a large fraction of people will go along with the crowd. So everyone gives the wrong answer, and a large fraction of people will go along. They'll give the wrong answer as well. They'll feel uncomfortable. They'll look again, but they'll give the wrong answer. Possibly it's just part of that is not wanting to stick out, but that's a fairly simple and behavior that occurs in a widespread way across lots of people. There's a more recent study that repeated this using brain imaging, and I can't remember the exact region, but they found that the region that was lighting up when people were making their decisions wasn't the part involved with kind of reasoning ability, where you think, well, should I or should I not? Do I want to stick out? No, I don't want to stick out. I'm going to go ahead. It was the part of the brain that's involved in perception, which suggested that people were actually seeing the line as being the longest, even though it wasn't. So if it can operate on that really basic level of perception, then this kind of herding behavior is really fundamentally deep in our psyche. That's just one example. There's lots of these kind of things. So I talked a little bit about that in the book. I just didn't have time to go into that today.
No more questions?
I don't remember the details, but there's some recent work about group intelligence being, how democracy makes a better choice than smart people or something.
Well, there's this book, The Wisdom of Crowds, of course, kind of follows that theme. Get lots of people, as long as they're thinking independently and feeding independent information into some decision process, then it works. If you get people starting to do, just like this Ash experiment, where two people say what they think and everyone else follows, then that doesn't give you good decision making. Right?
But to the extent that gives you good decision making, it would have an evolutionary value.
Yeah.
These,
yeah, no doubt. Yeah.
things.
Yeah.
Having explored these ideas for a while and maybe come to some interesting conclusions on your own, have you seen that this changes your behavior? How you think of your own behavior, what you do, the choices you make every day?
I don't know. I don't think so. I just go blunder along unconsciously like I always did before, I think. Yeah.
This is not a serious comment or a question, but for those who are fans of Isaac Asimov's science fiction, this sounds a lot like psychohistory in his Foundation series, if you've read about it.
Yeah.
It's something I wanted to ask, actually. Harry Seldon's work.
So are you familiar with them?
I'm not actually, no. I've heard of it, but I've never read it. No.
And he talked about it in
predicts human futures.
Right.
Can you make any substantive predictions? Like, for instance, you were talking about how people organize. Can you make a substantive prediction, say, can you post-dict, given the, ethnic makeup in an area in 1970, can you post-dict forward and get the correct answer for today?
I haven't seen anything that can do that. And in fact, I mean, this Schelling model I haven't seen it really be used as a tool for understanding empirical racial segregation. It's used just to make a conceptual point that it's not clear that racial segregation implies racist attitudes. There is this mechanical aspect to it.
And one other question, I've heard about some large organizations, McDonald's, Home Depot, things like that, knowing exactly where to put their stores based on inputs and having a computer program that kind of, figures out where the building is going to be in an area and where the people are going to choose to live and that sort of thing.
Yeah, I don't know anything about that. I haven't come across that. Yeah. I know there's some recent work. There's a guy, this isn't in the book, I just learned about it since then. There's a guy at MIT named Alex Pentland who he's a weird combination between like electrical engineer, electronics guru, and social psychologist. So he's doing experiments where he wires up whole organizations with little devices. So sometimes they're modified cell phones or built from scratch things, and they record location very accurately, and they take data over like months. They also record upper body, having a little accelerometer, so it records upper body movements. It records voice, not actual words, but just tone of voice and amplitude, tone. And then he takes all this data and he feeds it through signal processors and just looks for mathematical patterns. And he finds that some simple patterns, that people, a lot of communication happens non-verbally. So you take people in negotiations, mock negotiations, they talk for 45 minutes trying to come out ahead. One's supposed to be the middle manager, one's the president, and middle manager's hoping for a promotion. So they're arguing, this is people at a business school, they argue for 45 minutes, and afterwards they'll tell you, well, how it went, who came out on top, and why, and give you lots of reasons. Well, I used this strategy, and partway through, he made a mistake, and I got the advantage, and that's why. But in fact, they can take like 15 seconds of this data at the beginning and predict with 80% accuracy who's going to come out on top. So, and what it tends to do is there are certain kinds of patterns of behavior, like mimicking. Well, one is called mirroring or mimicking. So you mirror what the other person is doing, and this kind of conveys an empathetic response or standpoint, attitude. And then there's a kind of more dominant attitude, which is you don't have much variation in your voice. You talk in a monotone because you know what the truth is, and you are the authority. And the president tends to do better if he has more of this dominant behavior. The middle manager does better if they have more of the mirroring behavior. But the interesting thing is that you can record these things. The computer alone can make the prediction 80% of the time. You don't need a person to do it. And so this is a really fascinating area because he follows these people for months, and he can track and look at what the audience was feeling and how they were behaving when someone was giving a lecture, because all their data is being recorded. Upper body movements, betray a little bit of boredom, and I wish the guy would just stop talking, that kind of stuff. So that's going to be growing more and more in social science as well. You gather all this data and then find new ways to analyze it.
I feel a bit of a need to quibble with your characterization of racial segregation in not being indicative of racist attitudes. But you've said it twice now, so I want to take issue with it. Right. If I leave an area because other people are treating me in some different way, exhibiting racist behavior, then there's certainly racist behavior going on amongst others. If other people are not treating me any differently, there's no racism going on amongst other people, but I feel uncomfortable in that area because I'm a minority, then I'm exhibiting racist behaviors.
Okay.
Either way, there's racism going on that's causing this racial segregation.
Okay. Yeah, it depends on whether you want to call the preference not to be an extreme minority. What do you call that? Yeah.
I call it racism.
Okay, that's fine.
I'm not being treated any differently.
I have no quibble with that. That's fine.
So in looking that,
sorry.
So in the simulation that you actually showed for that experiment, where the colors segregated, what was the threshold for extreme minority? Is it just you're the only person in that locality of that color?
No, I think that was like 30%. So if you looked, I'm not sure how big you looked out for the neighborhood, but you draw a circle around yourself and you count up within that volume how many people are your color. And if it's less than 30%, then you move out. And you can do, it doesn't affect much. If you do 20%, 30%, 35%, you still get the same kind of outcome.
Well, because if I keep it like an extreme minority being, I'm the only one of this color in this area, and even if there's one other person, then it's not an extreme minority anymore. Then you won't see these enclaves, right?
If you go down to the 1% level, say.
Just one being the extreme minority. You're the only one of that kind in that enclave. I mean, it depends on what is an extreme minority.
Yeah. That would be a very extreme minority. Yeah, I don't want to quibble over the definition of racism, certainly. Yeah.
What's the basis for assuming that if you start with the premise that color is meaningless in that experiment, but then you assume that I'm going to have a weak preference for not being around others of different color?
Yeah, that's a different model. That's the So the colors are meaningless in the model that's looking at ethnocentrism.
Okay.
Right. And they're definitely...
That might be problematic, right? I mean, minority status might, minority status I might not notice that I'm a minority if color is meaningless. I mean, I might find myself being among a lot of different colored people.
Right.
But think, well, they're all liberals, they're all...
Yeah, well, the Shelley model assumes at the outset that you have some small preference, very small, to be with the similar color, or at least not to be only with the other color, mostly with the other color. All right, so that assumes that at the outset. That's in there. The ethnocentrism model assumes that color starts out being really, truly, totally meaningless. It doesn't tell you anything about whether a person is likely to cooperate or not at the outset. But you get a correlation between colors segregate and people become ethnocentric, adopt the ethnocentric strategy. So in the long run, color does have a meaning for you. If you're a red person, you have to be aware of this. You're not going to do very well if you don't pay attention to the fact that most people are ethnocentric, and so the other colors aren't going to treat you very well. So it takes on a meaning, even though it doesn't.
No, yeah,
Right.
I got that. The other model doesn't assume that color isn't meaningless. I mean, it just
No, it assumes
that we
that
start out already feeling.
It assumes that it has a weak value, and I think the surprise is that it leads to such a strong, separation of the people into two different enclaves. It's counterintuitive that such a.
Wouldn't you get really different results though if you said, well, I have a weak preference for being amongst people of my own color, but I also have a weak preference for being amongst people of my own, social class or economic class, and then if you start throwing those things in, do you still end up with the same?
I imagine there's a whole world of conceivable models you could explore that would give different results. I just use that model as a way to get across the idea of this counterintuitive outcome at the large scale that is not obvious when you think about the small scale.
So it looks like what you're looking at here is emergent behavior.
Yeah.
And is it in looking at this across all the spectra you have, is it your intuition that all of this emergent behavior comes from fairly simple rules applied at the local level, or do you think that the rules are pretty sophisticated, or do you think that, because some of these models you showed have such simple rules that I would just imagine there couldn't be any other emergent behavior, like the Snelling model and the ethnocentric one. But, the more intriguing one was matching the markets and real markets.
And that is a fairly sophisticated behavior. The agents are highly adaptive, and you do get different results depending on, these come out of there's a body of work in the physics literature. There's a game called the minority game. So you get a group of people, 101 people, and at each time step you select either 0 or 1. And what you want to do is you want to select the number that most other people don't select. And so how do you do this? You have no knowledge beforehand of what they're going to do. So the only way to try to do this is to make up strategies. So you look at past behavior. What has the majority done? And it's a string of zeros and ones. And then you build strategies that try to predict from strings into what the next outcome is going to be. And so the little artificial agents, you do this, they tend to say that they have a brain size. And the brain size, it's like let the brain size be m, then I think it's 2 to the m is the length of time in the past they look to try to predict the future. And these models, they do change if you alter the brain size of the people. You can find interesting phase transitions as well with the number of people who are involved in the market. So at the outset, if there are very few people involved in the market, that means that there's not enough people to kind of fill the space of possible strategies. And in that case, there's some residual predictability in the outcome of the market. So some new person can come in and use some strategies to make money in the market case. But as more people come in and start to fill up the space of strategies and pack it densely, then you get to a point where the predictability is washed away and you get an effectively random signal. And then it becomes not profitable to be in the market anymore, so people are going to get out. So this is a case where you kind of get this natural evolution right to the edge of bare predictability, where it's difficult to find any patterns, but maybe just possible, at least when not too many people are in the market. But yeah, it's a very rich kind of problem, even though it's still a very simple model.
Great, thank you very much.